Hello, my name is Kaleab and I'm one of the presenters at the AAAI UC Consortium. So I'm going to start my presentation by talking about what pruning is. Pruning a neural network is the process of removing edges or nodes from the neural network. It is usually done to reduce the number of parameters of the neural network so that it consumes less memory or does not overfit to training samples. It's also done in an iterative fashion to avoid the deletion of essential neurons and connections. Deep neural networks have immense computational and memory requirements that make them difficult to use in low-resource environments. The more dense the network, the more parameters it has, and the less usable it becomes in low-resource environments. Highly dense networks are also overparameterized and prone to overfitting. Traditional techniques for preventing overfitting, such as dropout, do not improve computational and memory usage requirements. There are numerous effective neural network pruning schemes that have gained widespread acceptance in the machine learning community. In their paper, Optimal Brain Damage, Jan LeCun and his team propose a pruning scheme whereby the second derivative of the objective function of the network is computed to calculate its saliency. Low saliency parameters are removed after each step. In a closely related work to ours, Han Song and his team propose a magnitude-based pruning scheme in which all weights whose magnitudes fall below a specific threshold are removed and the remaining weights are readjusted in the next round of training. The major drawback of the approaches mentioned earlier is that they require the model to be retrained for pruning before pruning is carried out, resulting in a 100% performance overhead. Our proposed method avoids having to retrain the model by performing pruning online or while training is ongoing, instead of relying solely on the magnitude of the weights to determine whether we should prune a weight or not. We observe the value of their gradients to determine the rate of change of their magnitudes. Weights whose gradients fall below a specific threshold can be pruned because we can assume that their magnitudes have relatively settled to their final value. And pruning is, as mentioned earlier, carried out iteratively according to a schedule that was one of the model hyperparameters. So after performing our experiments, we were able to achieve 89.1% sparsity on the MobileNet architecture. The MobileNet architecture has above 13.5 million parameters. And after carrying out our pruning scheme, we were able to reduce the number of parameters by 89.1%, resulting in a network with only about 1.5 million parameters, with only a 4.1% reduction in accuracy, making it far easier to use in environments with few resources.